In 1a, we are asked to work out the value of 25 minus the root of 43.87 over 6 plus 2.1 squared, and we need to write down all the figures on the calculator display. So let me go on my calculator. We've got in the numerator 25 minus the square root of 43.87, and in the denominator we've got 6 plus 2.1 squared. So we've got an answer of 1.7652793. In part B, we need to work out the value of the reciprocal of 0.625, and when we talk about the reciprocal, we mean 1 over the number, so 1 over 0.625. Well, if I plug this on the calculator, I get an answer of 1.6. In question 2, we need to write 60 as a product of its prime factors. So I'm going to write 60 here and keep dividing by all prime factors. So 60 over 2 is 30, divided by 2 it's 15, divided by 3 it's 5, and divided by 5 is 1. So the objective was to arrive at 1 here. So we can see that 60 is 2 squared times 3 times 5. In question 3, we're told that we had 48 counters in a bag. Now the bag contained only red and blue counters in the ratio of 1 to 2. So red counters to blue counters is 1 to 2. And Helen has to work out how many red counters are in the bag. Now Helen says that there are 24 red counters in the bag because 1 is half of 2 and 24 is half of 48. And we need to say whether Helen is correct, giving a reason to justify our answer. Well, starting from the fact that the ratio is 1 to 2, I will say that 1 plus 2 is equal to 3, and therefore this means that the number of red counters will be found by considering a third of 48, because a third of the total number of counters is red. Now a third of 48 is 16, and therefore Helen is wrong. In question 4, we've got negative 2 less than or equal to n less than 5. Now n is an integer, and we need to write down the greatest possible value of n. So obviously n cannot be 5 because this is a strict inequality, and n being an integer means that the greatest possible value for n is 4. In part B, we are asked to show on the number line below the inequality negative 4 less than or equal to m less than 1. Well, I will start by drawing a full circle on negative 4 because at negative 4 we've got an inclusive inequality, and then an empty circle at 1 because this is a strict inequality, and I join them together. So m could be anything between negative 4 inclusive and 1 excluding. In part C, we need to solve the inequality 2 over 5g minus 4 is less than 6. So I will start by moving the negative 4 on the right hand side. So 2 over 5g is less than 10. I will cross multiply. 2g is less than 50, leading to g is less than 25. So the solution is g is less than 25. In question 5, we're given the triangle and the rectangle shown here. All measurements are in centimeters, and additionally we are told that the area of the triangle is 10 square centimeters greater than the area of the rectangle, and we need to work out the value of x. Well, we know that the area of the triangle is given by base times height over 2, so we're looking at 6x times 8 over 2. And this is equal to the area of the rectangle, which is base times height. So I'm going to write here 5 times 4x minus 1 plus 10, simply because the area of the triangle is 10 more than the area of the rectangle. So I see that the 6 with the 2 simplify to leave me a 3 in the numerator. And if I expand the brackets, I get 24x is equal to 20x minus 5 plus 10, leading to 4x is equal to 5, and therefore x is 5 over 4. So my final answer is that x is equal to 5 over 4. In question 6, we are told that last year a family recycled 800 kilograms of waste. Now 57% of this waste was paper and glass, and the weight of paper recycled to the weight of glass recycled is 12:7, and we need to calculate the weight of glass the family recycled. Well, I will start by doing 12 plus 7 is equal to 19, and therefore this means that the weight of glass is 7/19 of the paper and glass. So we can see this from the ratio. So 7 corresponds to glass, so 7/19 of the paper and glass is the weight of glass. Remember, we're trying to find the weight of glass, which will be given if we do the calculation of 7/19 times the 57/100, which is the 57% that we were given in this second line here, times 800. Well, if I plug this on the calculator, I get an answer of 168. So 168 kilograms of glass was recycled. In question 7, we've got the number D rounded to one decimal place, and the result is 12.7. Now we need to complete the error interval for D. Now remember that in these cases, I will add an extra 0 after the 7, so 12.70. And then I'm going to go 5 up and 5 down, so 12.75 and 12.65. So my lower bound is 12.65, and this is inclusive, because if I happen to be at 12.65 exactly, then I'm rounding to 12.7, and my upper bound is 12.75, and this is a strict inequality because the 12.75 will go to 12.8, but anything just below the 12.75 will stick to 12.7, correct to one decimal place. In question 8, we've got Tamsin that bought a house for 150,000. This increases by 4% each year. And then we've got Rachel that bought a house for 160,000, increasing by 1.5% each year. At the end of 2 years, whose house has the greater value? And we need to show how we got our answer. Well, I will start by considering Tamsin. Now, Tamsin bought the house for 150,000. This is increasing by 4% each year. Now, an increase of 4% corresponds to a multiplying factor of 1.04. So this will be applied for 2 years. So times 1.04 squared, which gives an answer of 162,240. Whereas Rachel started off with a value of 160,000. However, it only increases by 1.5%, which corresponds to a multiplying factor of 1.015. This is also for 2 years, so it's going to be 1.015 squared, which gives an answer of 164,836. We can see that for Rachel, the value is greater than Tamsin, and therefore we conclude that we've got Rachel's house having the greater value. In question 9, we've got the cumulative frequency table below, giving information about the ages of 80 people working for a company, and we need to draw a cumulative frequency graph for this information. So I will be plotting the cumulative frequency against the class endpoint. So the point will be 30, 20, then 40, 48, and so on. So if I go on my diagram here on the grid, I will start by plotting the points. So this is the 30, 20, then the 40, 48, and so on. And then I will be joining them together with straight lines, or I can simply draw a smooth curve to join them together. And this is the cumulative frequency curve. In part B, we need to use the graph to find an estimate for the median age. Well, we know that the total frequency is 80, so 80 divided by 2 is 40. And then I'm going to go to the cumulative frequency diagram here. I'm going to go to 40 and go to the right to meet my straight line, and then go down to read off the value. So we can read off the value of 37, and therefore we conclude that the median age is 37 years. In question 10, we've got the bias dice thrown 60 times. The table here shows information about the number that the dice lands on each time. Now we throw the dice twice and we need to work out an estimate for the probability that the dice will land on 6 both times. So we can see out of a total of 60 rolls, 15 of them gave a 6. So according to the observed information, the probability of getting a 6 is 15 out of 60, which of course simplifies to 1 over 4, and therefore the probability we get 6 both times is simply going to be 1 over 4 times 1 over 4, because each of the rolls is independent. So 1 over 4 squared gives an answer of 1 over 16, so the probability required is 1 over 16. Now Sally is going to throw the same dice n times and record the number it lands on each time. She will now be using her results to work out a more reliable estimate for the probability in part A. And what can we say about the value of n? Well, the table here was based on a total of 60 rolls. So for a more reliable estimate, we need to have more than 60 rolls, so that we've got a bigger sample size, and therefore this results to a more reliable estimate. In question 11, we are asked to use algebra to solve the simultaneous equations given here. Well, I will start by labeling the first one with 1 and the second one with a 2, and I will multiply the first one with 3, leading to 6x plus 18y is equal to 15, and the second one with 2. This leads to 6x minus 8y is negative 24. So I've got the same number of x's here, so I will deduct one from the other to eliminate the x terms. Now 18y minus the negative 8y is 26y, and 15 minus the negative 24 is 39. This means that y is 39 over 26, which simplifies to 3 over 2. And then I can go to the first equation here, substitute for y to get the value for x. So we've got 2x plus 6 times 3 over 2 is equal to 5. So 2x plus 9 is 5, which means that 2x is negative 4, and therefore x is negative 2. So all in all, we arrive at x is negative 2 and y is 3 over 2. In question 12, we've got the points A, B, C, and D lying on a circle centered at O, such that ABCD is a rectangle measuring 8 centimeters by 10 centimeters, and we need to work out the circumference of the circle. Well, I will start by joining A and C together, and we notice that AC is a diameter. It's also the hypotenuse of the triangle ABC, so I can use Pythagoras theorem here to determine AC and therefore find the length of the diameter. So we've got AC squared is equal to 8 squared plus 10 squared, leading to AC squared is equal to 164. I will take the square root of 164 to get 2 root 41 for AC. Now recall that AC was the diameter, so the radius is simply going to be AC divided by 2, which is 2 root 41 divided by 2, which gives an answer of root 41. Remember, we're trying to find the circumference of the circle, so the circumference is simply 2 pi r, which is going to be 2 pi times the radius of root 41. If I plug this on the calculator, I get 40.232 ... which correct to 3 significant figures is 40.2 centimeters. In question 13, we're given ABC, the triangle shown here. We've got the angle B, we've got the length of AB and the length of AC. We are told to calculate the size of the angle BAC. It's the angle I'm showing here. Now, we can't find directly this angle here, but I can concentrate on the angle C here and use the sine rule to determine C. Once I've got C, I can use the fact that angles in a triangle add up to 180 degrees to find the missing angle A. So let's start with the sine rule. We've got sine of 70 over the 18 being equal to sine of c over 15. So if I cross multiply, I get 15 sine 70 over 18 is equal to sine of c. I will now do shift sine of the left hand side, which gives that the angle C is 51.543 ... and therefore the angle A, which is what we're trying to find here, is 180 minus the 70 plus the 51.543 ... This gives an answer for A of 58.4568 ... which correct to one decimal place is 58.5 degrees. In 14, we need to show that x squared minus x minus 6 over 2x squared minus 5x minus 3 may be simplified to the form ax plus b over cx plus d, where a, b, c, and d are all integers. So let's start with what we're given. In the numerator, I've got x squared minus x minus 6, and in the denominator, I've got 2x squared minus 5x minus 3. Of course, the first thing to consider is factorizing both the numerator and the denominator. So the numerator gives me x minus 3 times x plus 2, whereas the denominator factorizes into 2x plus 1 times x minus 3. Now the x minus 3 is a common factor, so I cancel it out. So this simplifies to x plus 2 over 2x plus 1. In question 15, we've got the first 4 terms of a quadratic sequence, and we need to determine an expression in terms of n for the nth term of this sequence. Well, we know that the nth term of a quadratic sequence, un, is given by an squared plus bn plus c, where a, b, and c are constants to be determined. Now, in this particular case, we've got u1, the first term, to be 3. So this is a times 1 squared plus b times 1 plus c, which leads to 3 is equal to a plus b plus c. Now u2 is 9, which is a times 2 squared plus b times 2 plus c, and therefore we've got that 9 is 4a plus 2b plus c, and u3 is 17, which is equal to a times 3 squared plus b times 3 plus c, and therefore we've got 17 being equal to 9a plus 3b plus c. So all in all, we're dealing with simultaneous equations in 3 unknowns. I will take the second and the first. So we've got 9 is equal to 4a plus 2b plus c, and 3 is a plus b plus c. And if I deduct one from the other, I get 6 is 3a plus b, which means that 6 minus 3a is equal to b. I will then consider the third and the second equations. So I've got 17 is 9a plus 3b plus c, and 9 is 4a plus 2b plus c. I will deduct again one from the other, leading to 8 is 5a plus b, and therefore 8 minus 5a is equal to b, and I can proceed in combining these two together to determine the value of a. So we're looking at 6 minus 3a is equal to 8 minus 5a, leading to 2a is equal to 2, and therefore a is 1. I will proceed in finding b. So b is 6 minus 3a, so 6 minus 3 times 1, which gives an answer of 3. And we also have that 3 is a plus b plus c, so 3 is a, which is 1, plus b, which is 3, plus c, leading to 3 is equal to 4 plus c, and therefore c is negative 1. And therefore we conclude that un is an squared, so 1n squared, plus bn, so plus 3n, plus c, so minus 1, so n squared plus 3n minus 1. In question 16, we've got the histogram giving information about the number of hours some students used their phones last week. Now the histogram is incomplete. Additionally, we are told that we had 28 students using their phones between 30 and 40 hours and 24 students using their phones for between 40 and 60 hours. And we need to use this information to complete the histogram. Now, notice that the vertical axis, the frequency density axis, is not scaled. So what I will do, I will start by drawing up a table looking at the two classes of interest. Now the 30 to 40 has a class width of 10 and the 40 to 60 has a class width of 20. We've got the frequencies, it's 28 and 24 respectively, and I will calculate the frequency density by doing frequency over class width. So 28 divided by 10 is 2.8 and 24 divided by 20 is 1.2, and this means I can scale my vertical axis. So this here is 1, this is 2, this is 3, and this is 4. And therefore, knowing that the 40 to 60 class has a frequency density of 1.2 means I can add the extra bar here and complete the histogram. So the 40 to 60 goes up to a height of 1.2. In part B, we are told that no student used their phone for more than 60 hours and we need to work out the total number of students. Well, let's start with what we know. We know that in the last class, the 40 to 60, we had 24 students. In the 30 to 40, it's 28. And we can see that if we multiply frequency density with class width, I'll be finding the frequency. So this first class spans from 0 to 20 and has a height of 1.6. So if I do 20 times 1.6, I get 32 students here. And the class between 20 and 30 has a width of 10 and a frequency density of 3.6. So if we do 10 times 3.6, we get 36 students here. So all I need to do is add these numbers up. So we've got 32 plus 36 plus the 28 and then the 24, the 4 classes here, gives an answer of 120. So we've got 120 students in total. In 17a, we need to show that the equation x to the 4 minus x squared minus 5 is 0 can be written as x is the fourth root of x squared plus 5. So seeing the fourth root here means it makes sense to start by isolating the x to the power of 4 term. So x to the 4 is x squared plus 5, and therefore x is the fourth root of x squared plus 5 as required. Now in part B, we are asked to start with x not being 1.5 and use the given iteration formula 3 times to find an estimate for a solution of this equation here. So we will start with x not being 1.5. I'm gonna go on my calculator, I press 1.5 and I press the equal sign. So I've just stored this on my answer key, and then I'm gonna do the fourth root of the ans squared plus 5, and each time I press the equal sign, I'll be getting a new iteration. So I press it once and I get x1 to be 1.640909. I will press it again for a second time, so 1.665398, and then finally for x3, remember we're trying to do this 3 times, I get 1.669763, and therefore we conclude that the solution is 1.67 to 3 significant figures. In 18, we are told that the ratio of 2a to 5c is 6 to 25, and the ratio of 4b to 7c is 20 to 21, and we need to show that the ratio of a plus b to b plus c is 17 to 20. So the first statement simply means that 2a over 5c is equal to 6 over 25. I will cross multiply to get 50a is equal to 30c, which means that 5a is equal to 3c, and therefore a is equal to 3c over 5. And we also have that 4b over 7c is equal to 20 over 21. I will cross multiply again to get 84b is 140c. If I divide both sides by 28, I get 3b is equal to 5c, and therefore b is 5c over 3. Now let's consider the ratio of a to b to c, which I can express entirely in terms of c because I've got a in terms of c and b in terms of c. So this means we're looking at 3c over 5 to 5c over 3 to c. So I can multiply throughout by 15 to get rid of the denominators. So we're looking at 9c to 25c to 15c, which of course simplifies to 9 to 25 to 15. And therefore, if I consider a plus b to b plus c, now a plus b will be 9 plus 25. And then we've got the b plus c, which will be 25 plus 15. So we're looking at 34 to 40, which simplifies to 17 to 20 as required. In 19, we're given the triangle ABC. Here it's a right angle triangle with AB being 9.3 centimeters and AC being 12.6 centimeters. Both measurements are given to the nearest millimeter, and we need to calculate the lower bound for the size of the angle marked X, and we need to show all the working. Well, I will start by converting the measurements from centimeters into millimeters. So we're looking at 93 millimeters and 126 millimeters. Now we can recognize that AB is the opposite side and AC is the hypotenuse. So this involves sine. So sine of X is equal to opposite of 93 over hypotenuse of 126. I will now take into account the fact that these measurements are given to the nearest millimeter. So we've got 93 being between 93.5 and 92.5. And we also have the 126 being between the 126.5 and the 125.5. So we're trying to make X as small as possible. So what I will do, I will make the AB as small as possible, and I will make the AC as large as possible. So we've got sine X being 92.5 over the 126.5. So I'm minimizing the numerator and maximizing the denominator. If I do shift sine of the right hand side, I get X is 46.989 ... and therefore we conclude that X is 47.0 degrees to 1 decimal place. In question 20, we've got ORT being a triangle. The vector OT is A, as shown here. The vector RT is B. Now, M is the point on OR such that OM to MR is 2 to 3. And we need to express MT in terms of A and B, giving our answer in its simplest form. Well, the first thing I will write is that OM is 2 over 5 and MR is 3 over 5. So we're trying to find an expression for the vector MT. So to go from M to T, I can go from M to R and then from R to T. Now the vector MR is simply 3/5 of OR. So let me write here 3 over 5 times OR. The vector RT is the vector B, so I can proceed. This is 3 over 5. Now the vector OR is simply going to be the A minus the B. So we are looking at A minus B, close brackets, plus B, which leads to 3 over 5A minus 3 over 5B plus B. I will be collecting like terms together, taking me to 3 over 5A plus 2 over 5B. Now alternatively, I could have said that the vector mt is equal to the vector mo plus ot. Now to go from m to o is simply 2/5 of ro. So let me write this down. We're looking at 2/5 of ro, and the vector ot is simply the vector a. So we're looking at 2/5 of b minus a plus a, which gives me 2/5b minus 2/5a plus a, which simplifies to 2/5b plus 3/5a, which of course agrees with the answer we obtained here, so both approaches are equivalent. In 21, we're given a graph of y is f of x, it's this shape here, and on the grid below we need to draw the graph of y is f of x minus 4. Well, f of x minus 4 is a translation 4 units down, which simply means we need to be deducting 4 from y. So if I draw the original f of x on my grid here, I'm gonna move 4 units down, and this is f of x minus 4. And in part B, we need to draw the graph of y is f of minus x. So this transformation here simply means we multiply x by -1, which is essentially a reflection along the y-axis. So this is the original f of x here on the left-hand side of the y-axis. If I reflect it along the y-axis, I get f of minus x. In 22, we've got only blue pens and red pens in a box. Now the number of blue pens is 4 times the number of red pens. Rita will take at random 1 pen from the box. She records the color and replaces it in the box. She will do this n times, with n being greater than or equal to 2. And we need to write down an expression in terms of n for the probability that Rita will get a blue pen at least once and the red pen at least once. So I will start by saying if the number of red pens is x, this means that the number of blue pens will have to be 4x, because we are told that the blue pens is 4 times the number of red pens, and therefore the total number of pens is 5x. So we've got the probability of choosing a red pen to be x over 5x, which is 1/5, and therefore the probability of choosing a blue pen is simply 4/5. Now I need to write down an expression in terms of n for the probability we get the blue pen at least once and the red pen at least once, and I need to realize that this is 1 minus the probability that all pens are red, so all red, or all pens are blue. So if I deduct these two scenarios, then everything that is left includes at least 1 red and at least 1 blue. So we're looking at 1 minus the probability that all of them are red is 1/5 raised to the power of n, because each time I'm drawing a pen, the probability it's gonna be red is 1/5, because I'm putting it back in the box each time I draw one. And the probability that all of them are blue is 4/5 raised to the power of n. I've got n identical draws. Each time the probability is 1/5 and 4/5 respectively. So this expression here simplifies to 1 minus 1/5 to the power of n minus 4/5 to the power of n. In 23, we've got 3 similar triangles, ABG, ACF, and ADE. We are told that the ratio of AB to BC to CD is 1:2:3, and we need to show that the area of the triangle ABG to the area of the trapezium BCFG to the area of the trapezium CDEF is 1:8:27. So 1 plus 2 plus 3 is 6, which means that AB is a sixth of the total distance AD. Then we've got 2/6 for BC and 3/6 for CD, which means AC is 3/6, and then AD is 6/6. and we can easily conclude the scale factors for the lengths. So for the triangle ABG, I will multiply by 3 to get to the triangle ACF, and then from the triangle ACF, I will multiply the 3/6 by 2 to get to the 6/6. This will be useful because we are looking at similar shapes. So let me draw the different triangles here. We've got the triangle ABG, we've got the triangle ACF, and then the big triangle here, which is the ADE. And I will also consider the lengths. So we start with a multiplying factor of 3 and then a multiplying factor of 2 as explained. So if we start with 1, we go to 3, and then we go to 6. And if we consider the areas, we know that the scale factors will be squared because the area is a square quantity. So it's going to be times 3 squared and times 2 squared. So if we start with 1 times 3 squared is 9, times 4 squared is 36. So if the area of ABG is 1, then the area of ACF is 9, and we know that the small triangle ABG is 1, and therefore the trapezium BCFG will be 9 minus 1, which is 8, and then for the triangle ADE, its total area will be 36. We already know that this is 1 and this is 8, so this will be 36 minus 1 plus 8, which gives an answer of 27, and therefore we can safely conclude that the ratio of the area of the small triangle to this trapezium will be 1 to 8 to 27 as required. In question 24, we've got 8 identical regular octagons joined to enclose the shaded shape shown here. Now each octagon has sides of length A, and we need to find in terms of A an expression for the area of the shaded shape, giving our answer in the form P times 2 plus root 2A squared, with P being an integer. Now we know that the side of each octagon is A, so I'm going to put an A here. I will draw 2 diagonals, and we can split this shape here into 2 triangles. So we've got the small triangle here in red and the big triangle in blue. So I'm gonna call the area of the red triangle A1 and the area of the blue triangle A2, and I will start by finding the angle theta shown here, which is an exterior angle of the octagon. Well, we know that the sum of the exterior angles is 360 degrees for any polygon. In this case, we're looking at a regular octagon, so theta is going to be 360 divided by 8, which gives an answer of 45 degrees. So I can extract the red triangle here to see exactly what's happening. So we know that the side here is A and this is also A. The angle at the base is 45 degrees, and this being an isosceles triangle means that this is also 45 degrees, which makes the third angle a 90-degree angle, and I can easily find an expression for the area of the small triangle A1, which is base times height over 2, so this is A squared over 2. The overall plan is to find expressions for A1, A2, and then multiply them by 4 because I've got 4 identical big triangles and 4 identical small triangles. I will now focus on triangle A2 to obtain an expression in terms of A for the area A2. So let me extract this whole situation here on the right hand side. We know that this side here is A and this side here is also A. Remember, I'm trying to obtain an expression for the base and then the height so that I can proceed with A2. Well, I will call this distance here x, so this is also x, and this here is simply A plus x, because if we look at the triangle here, this height here is simply the A plus the x, which is this distance here. So A plus x is the height of the blue triangle. Now I will proceed in finding x, and I'll be using cosine. Cos of 45 is x over a. So I've got root 2 over 2 is equal to x over a, leading to root 2 over 2 times a being equal to x. So the base of the blue triangle, we can see it's a plus x plus x plus a. So it's going to be 2a plus 2x, which leads to 2a plus 2 times the root 2 over 2 times a. Now the 2 with the 2 will cancel out, so we get an answer of 2a plus root 2a. I will factor out the a, so we're looking at a brackets 2 plus root 2. I will proceed with the height, which we said is a plus x. So this is a plus root 2 over 2a. I will factor out the a, leading to a brackets 1 plus root 2 over 2. And therefore the area A2, it's the area of the big blue triangle. It's going to be base, which is a times 2 plus root 2, times the height, which is a times 1 plus root 2 over 2 over 2. So base times height over 2. And then I will proceed into expanding. Now a times a is a squared. Now 2 times 1 is 2. Then I've got 2 times root 2 over 2, which is root 2. Then I've got root 2 times 1, which is root 2. And then I've got root 2 times root 2 over 2, which is 2 over 2, which is 1. So I've got 2 plus root 2 plus root 2 plus 1, and all of it divided by 2, leading to a squared brackets 3 plus 2 root 2, and all of it divided by 2. So I can proceed for the shaded area. So we said we've got 4 times the a1 plus the a2, so it's going to be 4a1 plus 4a2. We have found a1 to be a squared over 2, and we have found a2 to be a squared times 3 plus 2 root 2 over 2. So let's proceed with simplifying. The 4 with the 2 leaves me a 2, and similarly here. So all in all, we are looking at 2a squared plus 2a squared times 3 plus 2 root 2. Now we'll expand this further to get 2a squared plus 6a squared plus 4a squared root 2, which is 8a squared plus 4a squared root 2. I will factor out the 4, and then I've got the a squared here on the right, and within the bracket I've got a 2, so that 4 times 2 times a squared is the 8a squared, and then 4 times root 2 times a squared is the 4a squared root 2, concluding that the shaded area is 4 brackets 2 plus root 2 close brackets times a squared.